The last type of limit we're going to look at is limits at infinity. So we have a few types. Okay, so when it's sine and cosine, that limit at infinity is just going to be positive or negative 1. And that's because we know the graph of sine and cosine, it just oscillates back and forth between positive 1 and negative 1. For everything else, we're going to look at the highest degree terms and simplify. Okay, and then from there, we might need to think about what happens as our x values approach infinity. So when you're simplifying, if you have a number on top, and then you're looking at a really big number as x goes to infinity on the bottom, if you have something divided by a huge number, that's just going to approach 0. It's going to continue to get smaller and smaller and smaller. But if it's the other way around, if you have a huge number on top divided by something on the bottom, this is going to get so big that what you divide by isn't really going to make a difference eventually, so that will approach infinity. So let's look at some examples. So I have the limit as x approaches negative infinity of sine of x over x. So this is not one of the ones where the limit is 1. That only works for sine of x over x when x approaches 0. Okay? So when it's an infinite limit, okay, you have to think about each part. Okay? So I would have sine. It's either going to be positive 1 or negative 1. Okay? And then over on the bottom, this is just going to be some really big negative number. So if I have 1 divided by a huge negative number, it's just going to be a teeny tiny small number. Okay? Same thing, if I have negative 1 divided by negative infinity, it is also going to be a teeny tiny small number, but just positive this time. Okay? But since I'm dividing by 0, whether it's positive or, since I'm dividing by infinity, whether it's positive or negative 1, both of those would approach 0. So this limit is going to be 0. And that's because we have infinity on the bottom. Now if I look at something kind of flipped around, okay, so I have the limit as x approaches this time positive infinity over 2x, or of 2x over cosine of x. Okay. So if I have 2 times infinity, that's just going to be a huge number on top. So I've got a huge number on top. Cosine, I know, is going to go back and forth between positive 1 and negative 1. Okay. So if I have infinity divided by positive 1, that's just going to be a huge number, which I'm going to just keep calling infinity. But if I have infinity over negative 1, that's going to give me a really big negative number. So this time I can see, since the infinity was on top, when I divided by positive 1, it gave me a huge positive number. But when I divide by negative 1, it gives me a huge negative number. So positive infinity and negative infinity, those are different. So the limit here does not exist. Okay. It existed on this last one because since infinity was on the bottom, that's going to give us 0. So whether it's positive 1 on top or negative 1 on top, since you're dividing by a huge number, either way, both the positive and negative 1, they're going to approach 0. So let's look at another trig one. So again, we've got an infinite limit. So whatever the trig function is, whether it's cosine or sine, and remember, if you have a limit problem and it's not in terms of cosine or sine, change it first. So what's going to be up here is positive or negative 1. As x approaches infinity, it'll just go back and forth. And then we're doing the square root of a really big number. So the square root of a really big number, even though we're making it smaller by square rooting it, it's still going to be a huge number. Because as this continues to get big, the square root will also continue to get bigger. So on this one, whether it's positive or negative 1, since I'm dividing by infinity, okay, that's going to give me 0 either way. Okay, so this limit is going to be 0. Now let's look at some that are not trig ones. I like these better than the trig ones. So when we're looking at the limit as x approaches infinity, Okay, you're looking at the highest degree terms on the top and the bottom, which would be the 3x and the x. Okay, eventually this gets so big that the plus 4 and the minus 1, they don't make a difference. Okay. So we're just looking at 3x over x. That would simplify to 3, and that is going to be our limit, because it's like we're going to have 3 times a really big number, so 3 times infinity over 1 times infinity. These numbers, they're going to cancel out. That's why it's just 3. So now if I look here, okay, again, I've got another infinite limit. So that's when it's not a trig one, that's when you just look at the highest degree terms. So I have 2x over x squared, okay, because these aren't going to make a difference. That's going to simplify to 2 over x. So this one, I still have an x left when I simplified. Okay, but always make sure you simplify first, because like on this one, when we simplified, we just got to our answer. But when you still have an x left, you then have to think about what happens as x approaches infinity. So 2 divided by a huge number is just going to continue to get smaller and smaller and approach 0. So this limit is going to be 0. I left the squared off this one. There should be a squared right there. So on this one, we've got the limit as x approaches negative infinity. Okay, so again, I'm just going to look at my highest degree term. So that's just a 3x squared and a 2x. You're always going to simplify. Then since I have an x left, I have to think about what happens as I approach negative infinity. So 3 times a really big negative number is just going to be a really big negative number. So we're going to have negative infinity divided by 2, which is just going to still be a really big negative number. So this limit will end up being negative infinity. Now one like number 7, this one's a little tricky, okay, because it's squared. So we need to FOIL this out. So the top is going to say x squared minus 6. The bottom, you're just going to do 2x minus 1 times 2x minus 1, which is going to give you 4x squared. And then if you multiply these two together and double it, that'll give you the middle term. So minus 4x, and then square that last one. So now I can look at my highest degree terms. So that's going to be x squared over 4x squared. Okay, the rest of this isn't going to matter as x gets so big. Okay. I'm going to simplify it. So the x squareds are going to cancel, and that'll just give me a limit of 1/4. So now this next one, my highest degree term is negative x cubed, and then on the bottom, it's x squared, so that'll reduce down to negative x. Okay, so I have an x left, so I got to think about what's going to happen as x approaches negative infinity. So if I have a negative times a negative really big number, that'll be a negative infinity, which is just going to work out to be a really big positive number, so positive infinity. Now let's look at one more. So we've got the limit as x approaches infinity of 4 minus 1 minus 3x squared over 2x squared. So to figure out this part, I have to figure out this part first. So again, I'm just looking at the highest degree term, so I'm just looking at those two. So that's negative 3x squared over 2x squared, which is going to make this part of the limit negative 3/2. Then I would do 4 minus a negative 3/2, so that'll end up being 4 plus 3/2. So 4 I'm going to change to 8 over 2 plus 3 over 2. That'll make my limit here 11 over 2. So if you have two parts, you do each part separately and then subtract the two.